But today, radioactive dating. You know, there's a lot of mythology around radioactive dating, and it gives the impression of being highly accurate, something that can't be refuted. Today I want to just talk about how it actually works. And I'm not going to go into all the structure of the atom and the radioactive decay and all that, but just look at it so that it makes it very, very simple. And you see, it's to do with time, and we've talked about time a little bit in this seminar, and time is really the crux of the worldview issue. And we showed the picture of the geological time scale, and these are very common in our culture, indicating that the world is millions and millions of years old. And this is the idea of evolution, the idea of naturalism. For everything to make itself, you need lots and lots of time. And 4.6 billion years is the age of the earth that we're told about. Within the biblical worldview, there's a sequence, there's a history that unfolds, and the Bible reveals that to us. Different events, different people are involved, we know their names. And within the biblical worldview, from the creation of the first man of the world, some 6,000 years. So there's a great contrast there when we're talking about time. And so that's part of the issue. Richard Dawkins likes to make the point that anybody that believes the world is just 6,000 years old is crazy. But time, a young earth kills naturalism. If the world is only 6,000 years old, then naturalism hasn't got a hope. Nothing could make itself by itself in that time. And so you've got evolution, and the crux is it's over millions of years. It requires a long time for these things to unfold within that framework to make it at all believable. And it's been known for a long time that time is the miracle worker. They don't have a miracle worker in the naturalistic worldview. There is no God that works miracles. And this guy, George Wald, in The Origin of Life, he says this: time is in fact the hero of the plot. Given so much time, the impossible becomes possible. The possible becomes probable, and the probable virtually certain. One is only to wait. Time itself performs miracles. So there's the miracle worker, time, which makes naturalism, it provides the time that's necessary to do what it requires to do. So, but an old earth destroys biblical Christianity. A young earth destroys naturalism. An old earth destroys biblical Christianity. And first of all, it destroys the credibility of the Bible. We read in Exodus 20, verse 11, for example, "For in 6 days," this is written by God's hand on stone, "in 6 days the Lord made the heavens and the earth, the sea, and all that is in them, but he rested on the seventh day." And so that was given to us, as a pattern for our week. And if it was over millions and millions of years, we'd be still waiting for our first day off. If it was each day was 1,000,000 years or 1,000 years. And it's clear that with the number 6 and days, that it's an ordinary day, 24-hour day. And we read in Genesis 1, verse 31, God saw all that he made, and it was very good. And there was evening and there was morning, the 6th day. So it's clear from the way the day is, the context of it, that it is an ordinary day. Many people, and I'm not going to go into it today, about can day mean a long period of time? Well, it can, under certain circumstances. If I talk about in my father's day, that was a period of time when my father was alive. It used to take 10 days to drive across Australia. 10 literal 24-hour days driving during the day, the daylight part of the day. So the word day's got 3 meanings just in that little sentence. And here it is, evening, morning, 6th day. It's clear that they're talking about 6 days of creation. So if the earth is billions of years old, an old earth destroys the credibility of the Bible. And there's a guy, Michael Roberts, he engaged, he's a geologist, and also he's involved in the Church of England in England, and he debates, tries to convince people that you can't take the Bible literally. He says, my primary aim is to demonstrate the age of the earth, for the simple reason that if the earth is more than 50,000 years old, and that's not particularly old, biblical literalism is a dead duck. He said, if I can persuade someone that the earth is at least 1 million years old, I consider the war to be won. In other words, you can't really take the Bible as it reads if the world is at least 1 million years old. So an old earth destroys the biblical worldview. It also destroys the goodness of God, destroys the credibility of the Bible, destroys the goodness of God. Because we have the geologic time scale, which was presented to us over hundreds of millions of years. And what's on the time scale? Death, suffering, and disease. Dead things. Animals killing one another. Disease in the fossil record. And so this doesn't reflect the goodness of God. And so an old earth destroys God's goodness. And we read in Genesis 1 verse 31, God saw all that he made, and it was very good. And if there's death and suffering and bloodshed and fossils and that, before God said this, or when God said this, then it destroys his credibility as a good God. An old earth also destroys the uniqueness of man. Because we read in Genesis 1 verse 26, the final creation. God said, let us make man in our image, in our likeness, and let them rule over the fish of the sea, the birds of the air, over the livestock, over all the earth, and over all the creatures that move along the ground. So God created man in his image. And we read in the biblical worldview that God created man at the beginning, on day 6 of creation week. But within the secular worldview, the naturalistic worldview, man appears right at the very end of creation. And often people in the universities presenting this worldview take a great delight in indicating just how insignificant humans are in the time scale of things on earth. They're just the last little tiny bit, almost insignificant. So you see, an old earth destroys the uniqueness of man. An old earth destroys the basis of the gospel, because we read, in the Bible tells us that man's actions brought death into the world, but evolution says death and suffering's always been around, and that's led to our existence. And so the basis of the gospel is man's actions bringing death into the world, requiring a penalty to be paid. It also destroys the credibility of Christ. And we read there, Jesus said in Mark chapter 10, verses 6 to 8, it's recorded, where Jesus was asked about marriage, and he said this, at the beginning of creation, God made them male and female. We've already talked about this, but this is what Jesus believed. At the beginning of creation, not at the end of creation. At the beginning of creation, for this reason, a man will leave his father and mother, be united to his wife, and the two will become one flesh. So they're no longer two, but one. And so you see, an old earth really destroys the biblical worldview. And with the great increase in teaching and promotion and growth in geology and geological understanding and geological philosophy in our culture, it's no surprise that the Christian church, we see some of the consequences of that. So time, that's why we're looking at time. A young earth kills naturalism. An old earth destroys biblical Christianity. And atheist Richard Dawkins on young earth creationists, he says this. He doesn't debate creationists because I don't think he likes to lose. But anyone who thinks that the world is less than 10,000 years old, he says, you have to be staggeringly ignorant, which most of them are. Or if you're not ignorant, you've got to be insane. So you see, the age of the earth is a significant issue. And the lay down sort of so-called winning stroke is radioactive dating. And that radioactive dating and the dating methods prove that the world is indeed millions of years old. So radioactive dating. Now the thing is, most people don't realize this, but all radioactive dates are based on assumptions. They're not scientific facts. And this is the key to understand how dating methods work. So I've set up a little experiment for you. You all look pretty bright and alert today. And so this little experiment illustrates how all dating methods work. So are you ready for it? I've set up this scientific piece of apparatus measuring cylinder. You can see that okay? And you can see that it's graduated so you can read it accurately. And see, for any dating method, what you need is something that changes with time. And in this case, this is just an example, what we've got that's changing with time is the water level in this cylinder is rising. So it's changing with time because there's a little pipe which is dropping water into the cylinder. And you can measure how much is in the cylinder, and you can measure how fast it's flowing in. And so this is basically scientific observations. This is making measurements. This is making accurate measurements of a process which is operating. And so that's all that's involved. Something that's changing with time, you make the measurements. And so in a smaller group, I would ask for a show of hands, but I put up a few options here as to what how long this water has been dropping into this cylinder. And so I'll just ask for a show of hands. So there's 3 different options. Who says that the water's been dropping into the cylinder for 2 hours? Anybody for 2 hours? So one person for 2 hours. Who says it's been dropping in for 10 hours? 10 hours. Yeah. So, and who says for 20 hours? Anyone for 20 hours? Well, 10 hours is a good number, isn't it? Because the rate is 30 millilitres an hour. The amount is 300 millilitres. And so you just calculate how many hours it would take to fill that up to 300 millilitres. And so that's cool. That's how radioactive dating works. Slightly different, but basically that's it. A process that's changing, you make the observations, and you do the calculation. Now the thing is, I set this experiment up, and in actual fact the answer is 2 hours. And so you put your thinking caps on and think, okay, what's going on here? 2 hours. Now, I can't get close enough to you to be able to get a response, but some people say, oh, the water might have been flowing in faster in the past. Is that possible? That's a possible answer. Another thing that people often suggest is, oh, there was some in there at the beginning, right? And that's possible, is it? And there could be some others. There may be some example of how water's been lost. You know, it's dripped out or splashed out on the way that we're going through. But the point is that we can't know really what the situation was in the past because we can only observe it in the present. Do you get that point? We can make very careful observations in the present. We can read the amount that's in there highly accurately. We can measure the rate very accurately with very sophisticated instruments. But the fact is we don't know what it was at the beginning because we were not there. And so we can assume that there was none. It seems reasonable. We can assume the rate that was always the same. It seems reasonable. Come up with an answer 10 and everybody's happy until somebody says it's the wrong answer. And then we need to change our assumptions so that we can get an answer that fits in with what we know the answer should be and what we're observing. And that's basically radioactive dating in a nutshell. All dating methods have got the same fatal flaw, is that you can't go back in time to make the measurements and make the observations that are necessary to be sure that your calculation is right. And no geologist, well, every geologist knows that he can't trust the numbers that come out of the machines because they're all based on assumptions. So he'll never just accept a number that comes out of the machine. But he changed his assumptions to fit in with it. So dating of rocks basically goes on the same sort of process. In this case, there's various processes, radioactive decay chains that are used, potassium to argon, which is a gas, or uranium to lead, there's also one that goes from thorium to lead, there's one from samarium to neodymium, and there's one from rubidium to strontium, and we could multiply that by another 10 times the number of different methods that can be used. And then there's magnetic methods, and then there's fission track dating. There's lots and lots of different methods that people use. All they need is something that changes with time to be able to do a calculation. And in the case of radioactive dating, it's not just a straight rate that remains the same, but the rate of decay or the amount of material changes with time. So within, as the radioactive element decays, isotope decays, when there's half left, that's called a half-life. And then after another half-life, there's only half of that left. There's a quarter and another half-life. There's half left and another one. And it goes like that. So it's an exponential decay in radioactive dating. And so that's fine. You can still do the calculation quite simply. The exponential decay gives it a little bit more of a mystery about it, a little bit more sophistication. You've got an equation which has got E in it to a certain power and with a lambda on it. And so that all looks very sophisticated, but it doesn't avoid the issue that you can't go back in time to make your measurements. You can only make measurements in the present. And in the case of potassium, it's potassium-40 decays into a number of, it decays into calcium-40 and also into argon-40, which is a gas, and the half-life of that is some 1.26 billion years. And so a particular isotopes are chosen which have got a long half-life, and by choosing isotopes with a long half-life, it's sort of biased towards giving dates which are very old. And also you get machines which are highly accurate. This is making measurements in the present. High precision argon mass spectrometer, which is basically the potassium-argon method, which uses a nuclear reaction to measure the amount of potassium. And this is a mass spectrometer. Incredible technology, high precision, but it doesn't measure the age. What it does measure is argon in the present. And so basically it uses a method, something like what we've described, where you've got something that's changing with time. So the key thing is, the take-home message is, there's no instrument that we've got, that anybody has, that can measure the age of anything, just by making measurements in the present. Every age calculation is based on assumptions. And the last one, which is a key in understanding this and demythologizing it, is that scientists change their assumptions in order to make sense of their measurements. They change their assumptions after they get their results back. And so they change their assumptions. Now, I'll just give you one example of this. It's quite a reasonably well-known one, but there's this lady here, her name is Kay Berensmeyer. She's in Africa. She's sitting on a layer of ash. It's a volcanic ash. It's given the name of KBS tuff. Tuff is another word for ash. KBS means Kay Berensmeyer site tuff. So she found it. And the significance of it is, this is an area in Africa where paleontologists are excavating fossils of elephant, pig, apes, and tools. They've also got what they believe are tools made by people. And so you've got this layer of KBS tuff, and what they want is to be able to put a date, a number, against the fossils. And so there's the layer of rock there. That's Kay Berensmeyer. And so some geologists by the name of Fitch and Miller, they collected some samples of the tuff, and they did an analysis of it by potassium-argon dating, and they came up with an age of 212 to 230 million years. And so this is just part of the process that they used. Did the calculations, standard assumptions, came up with this number. And the thing is, nobody believes a number unless it checks out with what you think's the right number. And so the question is, do you think there's a reasonable number? I'm looking at you people, and do you think it's a nice number? Do you like it? From a biblical point of view, it's way off, isn't it? But from a secular point of view, they thought it was way off too, because it's talking about fossils of elephants, pigs, and apes. So, but this number, 212 to 230 million years, is actually the dinosaur era within the naturalistic worldview. So they said, oh, there must be something wrong with this. And there's a number of standard ways of reinterpreting the results that you can sort of dismiss it without much discussion. And so they would say there seems to be susceptible to excess argon in this particular volcanic rock. So then they did some selection. And so that's what happens, is you select different minerals, different parts of the sample to see if you can get a number which is more appropriate. And they found a feldspar and a pumice in their sample, which gave an age of 2.61 million years. So what do you think of this number? Do you like it? Notice how precise it is, 2.61. It's not about 2, it's not about 3, but it's a really precise number. And that's the thing about radioactive dating, is you can make the measurements precisely, you can do the calculation and come up with numbers which have got a lot of decimal points on them, and it looks so accurate. And they looked at it and they thought, well, that looks all right, fits in with elephants, fits in with pigs, fits in with apes. So they're happy. They published the paper. It was in 1970 they published that. And other people were happy with it too. And in fact, other geologists collected other samples, and the number was checked by paleomagnetism and fission tracks, and it got the same answer. So everybody's happy. But one number was rejected, one number was accepted because it was a good number, the other one was not so good. But then later on, in 1972, a couple of years after that number was published, Richard Leakey, who's working in the area, found a skull underneath the tuff, beneath it, stratigraphically. And it was called skull KNM-ER 1470. And he was thrilled because if it's underneath the tuff, which is 2.61, this could be as much as 3 million years old. And so he published it. He's got a lot of articles in Time magazine, and all the other people are pushing a secularist philosophy in our culture. And he was happy. A lot of people are happy. But the other paleontologists were not happy at all. They said that skull is far too modern looking to be that old. There must be something wrong with the date. So they got no problem with challenging a date. I mean, but this is measured by radioactive dating. This is nuclear reactions. This is precise machines. You can't just challenge a date like that. Of course, there must be something wrong with it. Just look at the skull. And so they dispensed with that date. Some other people by the name of Curtis came out and did some analysis of it. And he came up with a date selecting various feldspars and selecting various pumice of 1.82 million years. Again, notice how precise it is. And he was happy. Other people were happy. And then some other geologists collected samples, and they checked it by paleomagnetism, got the same answer. Fission tracks got the same answer. And so everybody's happy now. But you see the process that occurs, the way it happens. And when you see the 1.82 million years, it just gives that air of finality about it, that this is the actual number that's measured. But in actual fact, all the people who are in the field know that you can toss it out anytime you like, and it can be tossed out. If somebody else comes along with a good reason and makes a good argument and comes up with another number, that'll be tossed out as well. And John Woodmarappy, creation geologist, he calls them trial balloons. Put a balloon up, it floats in the air, and if somebody comes along and shoots it down, well, that was no good. And if they don't, it stays floating. That's a good number. So you see, that's the way it works, is that radioactive dating is highly subjective. So that's just straight radioactive dating using the potassium argon method. And there's various other methods which can be used. One is the Isochron method. And based on this method, the Isochron method, the claim is that we can figure out, we can measure what the initial composition of the rock was, even though we were not there. So when anybody says that they can measure something in the past, you've got to say there's something fishy going on there, because you can't measure something in the past, right? So don't fall for it. And that claims they do not assume the initial concentration. So the idea is in the Isochron method, you collect a number of rock samples. And from this number of rock samples, you analyze them. In this case, say it might be the rubidium-strontium method, and you plot the various isotopes on a graph like this. So on the one rock sample, you plot where it falls, this one rock there, and then the other rocks, you analyze those, and you plot them on the graph, and they come up on the graph something like this, and it looks like they're sitting in a straight line. And so you draw a line through these samples, this graph, on this graph where they fall, and where they intersect at zero, that's said to be the initial condition of all samples. So it says that all these samples basically come from the same magma, the same volcanic eruption, the same magma chamber. So we collect these different samples from different parts and we plot them there. And that gives, and the samples, there's a bit of variation between them, but that doesn't matter because they all come back to the initial condition of the initial magma chamber of all the samples. So that sounds pretty reasonable. But actually, you're making lots of assumptions. You're assuming that each sample has got this same initial condition. You're assuming that each sample, it was in fact part of the same magma that the magma or the molten volcanic rock was nicely melted and that it was all mixed up so that it was all homogeneous, just like a nice cake, that you mix it up thoroughly. And so that's assuming that in order to be able to say that they all had the same initial concentration. But when you collect samples that are widely spaced apart, you can't be sure that they were part of the same magma. Because geographically, you might collect it from here and here and here. And so if you do collect them from places where they're close together, so you can be sort of say, well, I think I can make a good case for them being part of the same magma eruption, then they tend to all plot in the same point on the graph. You can't draw a line through them. So you have to select them geologically from a wide, fairly geographically wide situation, or different minerals. And when you do that, select them from places where they're not closely connected geographically, physically, then how can you be sure that it was the same magma? How can you be sure that it was properly mixed? You can't. And geologists know that. And so they interpret their results accordingly, according to the same thing as to whether it gives an answer that they like. Now, we've already talked about how potassium argon, how scientists change their assumptions to make sense of the measurements. Same thing happens with isochrons. Isochrons are basically these rocks which are supposed to have the same age. So here's an example. This is from Africa, in a country right in the middle of Africa. There was some volcanic lava in the border between these two countries. There were samples which were collected, and a rubidium isochron line was constructed after analysing the samples, and it gave an age of 773 million years. So there's a lot of laboratory work went into it, a lot of analysis, a lot of precision measurements, coming up with the graph and the calculation, 773 million years. And so the geologists looking at this said, well, these rocks actually look very young. It looks like they might have erupted in historic times. No, they're so much to the surface that they don't look old at all. And so totally rejected that and said, that must be a mixing line. As the lava came up, it must have collected sort of melted rock from this part and melted rock from this part. And so we've just got a line which is sort of mixed up with this other stuff, and so totally rejected it. So you see how that works. This just came out of the Principles of Isotope Geology from Fora. And that's was one of the standard texts on isotope dating. Here's another one in India, an amphibolite, which is a metamorphic rock, a black metamorphic rock in southeast India, in this place here, in the schist belt. And that was tested. Rubidium strontium isochron gave an age of 481 million years. So, people say all the dating methods agree. And so they did another test. It's actually unusual to do two different tests. Samarium neodymium gave an isochron of 824 million years. So it's twice the age as the first one. Now, does this make the people who are doing the test, does this make them think, oh, let's throw that radioactive dating out, it doesn't work, it's hopeless? No, it's all in the interpretation of the results. And so in this case, with the rubidium strontium method, what did they say? They said that the older age was the age that the rocks underwent metamorphism. While the younger age was when the rocks were later heated. So this is the idea, is this schist, this amphibole, this metamorphic rock. So the samarium neodymium, they say, oh, that 824 million years, that was when the ground was moved and the metamorphic reactions took place. That's when the metamorphism took place. And then later on, the area was heated. And that was 481. So you can see, you can interpret them any way you like. There's all sorts of things that you can do to reinterpret the results so that it makes sense or makes a story out of the answers that you get. There's a granite pluton, a volcanic pluton, that's in southern India, right down there. And the lead method, using the uranium and minerals, gave an age of 508 million years. But the potassium argon method gave an age of 450 million years. So different results. These are just published in a you can see the paper there where they're published in, the standard paper. And when you read the paper, you get no hint that there's a problem with the radioactive dating. There's no hint in it at all. But basically it's just said, okay, well, this is what happened, is this granite Pluton, it was molten magma, and then as it was cooling, the lead minerals, they became solidified and closed and cool enough so that they were able to retain their isotopes at 508 million years. And then over another 150 million years, something like, 50 million years, it was that long before the other minerals closed and were able to give a result with the potassium argon. So it's interpreted as being the cooling of this particular Pluton. And we talked before about how fast they cool these days. So there we see just a few examples to illustrate. First of all, to show that it's impossible to measure the age of something by making measurements in the present. And you can get any age you like, depending on the assumptions you make. And secondly, geologists don't accept it either. And they just change their interpretations to sort of make a story after the event. So dating the Earth, this is another particular thing. It's the same sort of thing, exactly the same process, same idea, is you need something that changes with time. And one of the guys that did some of the first work on this was a guy by the name of William Thomson, later became known as Lord Kelvin, and he was a physicist from Scotland in Glasgow, and in 1862 he published calculations of the age of the Earth. And in this calculation, he said it could be somewhere between 20 to 400 million years old. And how did he work that out? Well, you need something that's changing with time. And so basically, Lord Kelvin, he assumed the Earth cooled from a molten ball. That's the first thing. And so here's this molten ball. So he's assumed that it was once molten. And then as it cooled, he was able to do thermodynamic calculations as how the temperature changed. So how long would it take to go from the molten state to the condition that is in today, based on all the various assumptions about the various heat balances within the Earth. And these later calculations came up with an age of some 20 million to 40 million years, which is a long time. And this guy is a Christian. He was connected in with the church, and he was held up as being somebody who was really a stalwart for the Bible. But what does the Bible say? It says, in the beginning, God created the heavens and the earth, and it says the Spirit of God was hovering over the waters. So it never was a molten ball. See, and so it never had to take millions of years to cool from a molten state to its present condition. God created the earth to be inhabited right from the very beginning. But that age of 20 million to 40 million years was confirmed by other methods. There's a guy by the name of Helmholtz who assumed gravitational collapse on the sun, and from his calculations, assuming the various assumptions about the sun, he came up with an age of 40 million years. So here you've got two different methods, two different people coming up with the same age of 40 million years. But but of course nobody will accept an age if they don't like it. And Charles Darwin didn't like it. He called Lord Kelvin my sorest trouble, an odious spectre. That's what he called him. He was very nice about that. He's usually very polite, actually, Charles Darwin. And he says, I'm greatly troubled at the short duration of the world, according to Sir W. Thomson, for I require for my theoretical views a very long period before the Cambrian formation. Nowhere near old enough. For me, nowhere near old enough. 40 million years was too young. It was too young for uniformitarian geology, based on the assumptions that the present is the key to the past. And it was too young for evolutionary biology, assuming that things evolved. It required millions of years. And so there was this, even though accurate measurements, careful calculations based on physical laws gave these ages, people were looking for ways to get around it. And of course that came with the discovery of radioactivity, when Henry Becquerel discovered radioactivity in 1896. And so the debate on the age of the Earth continued. And so as soon as that was discovered, all the people who wanted a longer age sort of danced for glee and yelled out. So it's like a sort of political match, actually. And they said that the heat generated by the radioactive decay of the elements within the Earth this is what's keeping the Earth warm. And this is why the Earth is much, much older than Lord Kelvin was able to calculate, because of the discovery of radioactivity. But you know what? There's been, as people have done more careful analysis of the heat balances on the Earth, they've discovered that the Earth is not in equilibrium. And this celebration was premature. And the heat from the core and through the mantle and that sort of thing indicates that the Earth is not equilibrium. And so the long age is not really justified. Same with other planets in our solar system. Jupiter is not in thermal heat balance either, and creates, for it to be 4.5 billion years old, you'd expect it to be in thermal balance, but it's not. So the age of the Earth, the saga continues. Jupiter radiates significantly more heat than it receives. Now, one of the guys involved in radioactive dating was a guy called Arthur Holmes, and there was a lady who wrote a book about it, Cherry Lewis, called The Dating Game. And she said that, apologies to anybody who found this in the romance section of the library, but they tried to get her to change it from The Dating Game, some of the people who were her contemporaries. But this Arthur Holmes, it was the story of his life. He was a pioneer of geochronology. He produced the first radioisotope date in 1911, and he came up with the Earth's age at various stages of being 1,600 million years old. And the dates continued to increase as they analysed different rocks and as they used different methods. The age of the Earth continually increased from Lord Kelvin's 20 million. It crept up and up and up, and he came up with the date of 1,600 million years. And in Cherry Lewis's book, she says this. It's an interesting one. She says, a curious complication emerged in the late 1940s. If you've got the geochronologists measuring rocks, measuring the ages of rocks, it says the age of the Earth gradually crept upwards towards 3,000 million years and beyond. So it's creeping up. And she says, and eventually the Earth became twice as old as the universe. And that created a bit of a conflict between the astronomers, and Edwin Hubble was one of the guys involved in that, and there was a conflict between them and the geologists. And eventually that was settled, and the astronomers had to give in, and so now, it's all comfortably back together again. But the age of the Earth, how was it actually settled? It was settled by a guy called Claire Patterson, was the first person to publish a paper in which he gave the currently accepted age of the Earth. And what did he use? A rock? Did he use the salt in the ocean? What did he use for the age of the Earth? He used meteorites. A certain kind of meteorite, not any old meteorite, but an iron meteorite. And based on a selection of meteorites, he produced a isochron curve measuring the various isotopes, lead isotopes in them, and by drawing a line through them, and the slope of that line represents the age. That's what the idea is. And he calculated an age of 4.55 billion years, which is around the age, this is 1956, it's around the age that's still accepted now. Meteorites, so what's the point of meteorites? Well, the thing is that the assumption was, so you've got to make assumptions. So the assumption was that the Earth formed from a nebula, the nebula in space, and that meteorites are the leftover stuff, construction materials, from what the Earth was made out of. And so the meteorites, then they were assumed that they were intimately connected with the Earth. How would you know that? How would you know that? That's just a total assumption. And as a matter of fact, that's a nebular hypothesis. It's the way the assumption that it's based on. And Arthur Holmes, a pioneer in radioisotope dating, he said this: to use the isotope composition of lead from iron meteorites as part of the basic data for calculating the age of the Earth or its crust is unsound in principle. So why did he say that? Because how do you know the meteorites have got anything to do with the Earth? They came from the Earth, they formed the Earth. It's unsound in principle. It's just based on a wild guess. And he says the correct procedure is to use terrestrial materials. But he was a lone voice, and he didn't carry the day, that date of 4.55 billion years. is still the age that is very, very much accepted. And the thing is, what would be a good number for the age of the Earth? Well, Charles Darwin said 20 million years is far too young. 40 million years is far too young. And then, you don't want an age which is older than the age of the universe, right? So it can't be too big and it can't be too little. It has to be sort of just right to be able to fit in with naturalism. And so 4.55 seems a good number. There seems to be, in their minds, it's long enough for evolution to occur. It's long enough for geological evolution to occur, and yet it's safely lower than the age of the universe, which is supposed to be some 13, 14 billion years. It'll give you a couple of opportunities for a couple of generations of stars. So if anywhere between something like, 4 billion and 6 billion would probably be all right. And these meteorites give 4.55, so that's really good. And so it's been set in stone for quite a while. But the thing is, this Claire Patterson, who did the calculation, he based it on various assumptions about the formation of the Earth and the iron core of the Earth, and how it formed and the various processes. So he had some assumptions behind it. And what's happened, now known that his assumptions were wrong. And so he did his calculation, 4.55, based on assumptions which are now known to be wrong. And in this book, it says that Patterson was lucky. He was lucky. He got the right answer using the wrong method. Actually, remember when I went to school, if I got the right answer but using the wrong method, I didn't get any marks. You actually had to use the right method to get the right answer. And so that's to do with the age of the Earth. We can go, Patterson's results were more fortuitous than was realised 50 years ago. Isn't that incredible? Isn't that incredible? It's worth a read, that little book. It's quite a fascinating little thing. And you can buy it. I don't know if you get it in the romance section of the library, but The Dating Game is the name of it. You see, when we're talking about we've talked about radioactive dating. We've seen how the same process applies to the age of the Earth. And all dating methods are based on assumptions. You get any age you like, depending on the assumptions you make. And we can see why people want that sort of long age to fit in with naturalism. But there are a lot of geological arguments which have been used for an old Earth, which are now known to be wrong. And I'll just mention a couple of them. One of them is like diamonds are supposed to take millions of years to form. Millions of years to form diamonds. And yet there's a company in the United States called Genesis that manufactures them inside steel pressure vessels. And you've got a big steel vessel, and there's an inner vessel. They put carbon in the inner vessel, seal it up, close the lid, put it under heat and pressure, and within 4 days, out comes the diamond, which indicates that it doesn't take millions of years to form diamonds. And there's various creationist geologists have done testing on diamonds. Diamonds are carbon, a form of carbon, and they're supposed to be billion years of age. And this guy called John Baumgartner sent them off to the laboratory, carbon-14 laboratory, to be tested for carbon-14, which no geologist who believes in billions of years would ever do, because he would know that if they were that age, there'd be no carbon-14 in them at all. And yet, it was found that there was significant carbon-14 in these diamonds, indicating that they, solid evidence that they're only thousands of years old. But again, we can't really prove that the diamonds are only young. This is very good evidence that they're young. But the people who believe in billions of years are arguing against this evidence. And guess what they're arguing about? They're arguing about things that nobody can see, things that happened in the past that we can't go and check. They're saying, these diamonds must have been affected by this, or these diamonds must have been contaminated, or these diamonds must have had some nuclear reactions. So they're just inventing things in the past in order to be able to preserve the date that they like. Now, there are a lot of processes that give, when you do the calculation, a standard sort of reasonable assumptions, and you do the calculation, that they give an age for the Earth that's much younger than the billions of years. And one of them, I don't know if you're familiar with it, is the amount of sodium in the ocean. And you can work out how much is flowing in, you can work out how much is coming out, and based on those assumptions and the rate and the quantity in the ocean, you can calculate an age of 62 million years for the age of the ocean, which it should be thousands of millions of years for the ocean, not 62. And again, remember, This is the measurements in the present, doing a calculation about the past. And so every age, every calculation, every result is interpreted. So a person who's an evolutionist who believes in long ages, he would say, well, the age is too young. This particular method is not a good method for being able to calculate the age of the ocean because it's got these problems with it. But we have made a new discovery. It's never, that the age is wrong. This is a new discovery. Salt must recycle somewhere, or it must accumulate somewhere that we haven't discovered yet. And so, see how it works. It's never a problem, it's always a discovery. And so for the creationists, the age is too old. And so we can say that salt would have accumulated much faster during the flood. And so if you take the flood into account, it's 4,500 years ago, then we get the right age. And you could do another calculation, another process, something that changes with time, the erosion of the continents. And based on the current erosion rates, you can measure the amount of sediment going down the rivers of the world into the oceans, can come out with a calculation that the continents would be eroded away in some 14 million years. Far, far too young for the continents which are supposed to be thousands of millions of years old. And again, different interpretations of the results. The evolutionists would say the age is too young. A new discovery. That's the way it always goes, a new discovery. So whenever you hear some announcement about a new discovery, that we've discovered this stuff that was surprising, realize that they're really saying that their theories didn't work. And a new discovery, erosion must have been less in the past, or the mountains are uplifting, or something or other. Do you see how that works? And creationists, the evidence supports the continents being young, as we expected. There was a great amount of erosion during the flood, but there's been very little since. There was a project called the RATE group. I don't know if you've heard it, Radioactive Dating and the Age of the Earth. Quite a number of creationist scientists involved in that. This is some of them at the presentation which was made a few years ago. They published a number of reports. The last one, the Radioactive Dating and the Age of the Earth, Volume 2, with their results in it. And one of the things which was done, they collected some samples of rock from a drilling rig deep under the earth, and from that rig they collected zircon crystals. And these zircons are fairly tight, well-sealed crystals, and this is what they look like under an electron microscope. And they did quite some clever work on these zircon crystals. And Humphreys and Baumgartner, they presented it at the International Conference on Creation 2003. So this is a zircon, and within the zircon you have uranium enclosed within it, and it decays to lead. And by the assumptions, the normal assumptions which are made about this particular crystal, you can calculate an age, and it comes out to 1.5 billion years. But in the process of the uranium decaying into lead, it also releases helium, 8 helium atoms. And these would then leak out from the zircon. They're very slippery atoms, and you can calculate based on assumptions about the zircon and how tight it is. You can calculate how fast it would leak out, and there should really be none left, or next to none left. But there is measurable amount of helium within these zircons, and based on the calculations to come up with an age, that this zircon, instead of being 1.5 billion years, is some 5,500 years, more or less, plus or minus 2,000 years, which is a really good result, really interesting. But again, there's been quite a deal of discussion of this, on the various websites, on the atheist websites, on the rationalist websites, feedback on the creation.com and other websites attacking this. And what do they attack? It's always discussions about what happened in the past. On what the permeability and all that was of the zircon, and what its temperature was over billions of years. So you're talking about things which nobody can see, which nobody can measure, and really this is not objective measurements. You see, ultimately, you can't make measurements and prove that the world is old. You can't make measurements and prove that the world is young. You can come up with evidence that does point to it being young, and that's quite powerful in shaking people's minds. But ultimately, anybody who wants to hold an old earth can just throw up some assumptions that they come up with. And Russell Humphreys, who was involved in this, he talks about this on one of an article on our website. He's a physicist. He says, when at the time he began to discover scientific evidence for a young world, it was a huge shock. So he was surprised that there was all this evidence for a young Earth that on the face of it. And he says, when I submitted my first articles pointing to some young world evidence to secular science journals, the editors and the reviewers of those journals absolutely refused to publish some articles. Didn't even put it in the arena for discussion. Basically just censored it. And that's the way it goes. So how can we know the age of something? How can we know when things happened in the past? There is a way of doing it. And so just like science is based on the repeatable experiment, making observations in the present, history is based on people who lived in the past, who saw things happen and observed things which happened eons, a long time ago, and they recorded it. So the only sure way is by eyewitnesses and a written record. And that raises the question, of course, about how reliable are the eyewitnesses and how accurate are the written record and were they telling the truth. But this is basically the issue of what happened in the past. A birth certificate is an example of knowing the age of something in the past. Bill Jones, there was a doctor who saw it and a nurse who was there. And based on these people who signed the birth certificate, we can know the age of something. And that's how we know that Australia was founded in the 26th of January, 1778. The British flag was raised over in Sydney Harbour, Botany Bay there, by the people who sailed out to found Australia. And that's how you know, or we know, that the US Declaration of Independence was on the 4th of July, 1776, based on history. That it wasn't a matter of somebody taking a piece of the chair and doing a carbon-14 analysis on it. It's based on the documentation of people and the various events that happened. And that's how we know the age of the earth, is based on the historical record that's in the Bible. And you might have seen this little picture up here. It's a little bit hard to see, but actually right up the top there, you can just see that. That's a picture of Adam. You might have wondered what he looked like. There he is up there. And so you've got the genealogies going from Adam to Seth, and 130 years, and Seth to somebody else, and somebody else, and it goes all the way through, eventually reaches Noah. So you can calculate out very simply how many years it was between Adam and the flood, and then after the flood you've got Shem and going all the way down to Abraham and his son Isaac. It's all history, isn't it? We know what these people did. It's not a matter of mythology. It's not a matter of legend. It's basically history where they lived. It goes through King David, and one line goes through to Mary, as the mother of Christ. Another one goes through Joseph, who's the husband of Mary. And that's how we can know the age of the earth. So when we're talking about radioactive dating or anything like this, time, all radioactive dates are based on assumptions. That's really important to get. Any discussion you have, you just have to say, well, I don't agree with the assumptions that they make. And they're not scientific facts. They can be dressed up in scientific papers. They can look very convincing, but they're not scientific facts. They're just measurements made in the present and based on assumptions and models. But evidence and logic supports the biblical age of the earth. So we've talked about evidence. We've talked about lots of stuff to do with the logic of the age of the earth. And so time. The earth is young. The Bible records the only defensible, plausible, philosophically reliable way of knowing the age of the earth. So because the earth is dead, that means naturalism's dead. There's not enough time for naturalism to happen. So that's dead. Biblical history is confirmed. And God is good. Created a good world at the beginning, not a world that's full of death and bloodshed and fossils. People are special. God created us in his image right at the beginning. Sin is serious. But Jesus Christ can be trusted. His word can be trusted when he says from the beginning of creation, God made them male and female. And so we can know that we've been created for a purpose. And so I think that's really cool to once we understand that how fickle the dates are and how much manipulated they are, it really gives us confidence in being able to trust what the Bible says.